Hello, everybody, and thanks for being us with for this next session. We are here with the Jesus Escolar, a CEO of EXELERYS startup, one of our exhibitor companies today. Hello, Jesus. How are you doing?
Hello, how are you? I'm good. And
I'm
you?
good, thanks. I'm good, thank you. I would like to give a little introduction about him. So prior to the founding of EXELERYS, Jesus was working actively with the security vendors worldwide, providing the enablement and education across the different security issues the corporational faced. Um, okay, it's your turn now. Please tell us why we secure the DevOps and CI/CD pipelines in the cloud. This is for
Perfect.
Jesus.
If you allow me to share the presentation,
Yeah,
I will
please.
select the slide deck and I will start. So thank you very much for actually being here and the opportunity to speak in this event. So what we're going to talk today, and it's going to be very short because we only have 20 minutes. It's about the security in the modern ecosystem of developing applications and publishing solutions in the cloud, which is across the fact of using DevOps and using all the cloud native solutions. Once we get there, our goal is to understand how do we secure them. So if you look a little bit in the beginning of the infrastructures that existed in the world, we started with physical servers with different flavors of operating systems. We moved into virtualization with different kinds of hypervisors that were providing the base foundation of how to deliver those services. Then people started building cloud services to reduce the cost and simplify the deployment of their needs. So we started with Google Cloud, Amazon, Azure, IBM Cloud, VMware. And at some point, there was a situation where it was a need to actually reduce the footprint of these resources used in the cloud and actually compact them into a simplified, more flexible, immutable, and practical solution. And that was the invention or the democratization of containers. They became mainstream and they became useful. And after that, at the same time, there was a big explosion on how to use resources in the cloud, totally distinct, but connected via what we call serverless functions that actually interact between them and between the services that you actually publish in the cloud. But that's for another subject. We stay in the container side. So what is the concept of DevOps? So DevOps is an old concept that is being transformed into a new world. So it always existed, the fact that we have developers and we had IT operations. But at some point, when people started developing in the new platforms, outside of the old legacy systems, old physical servers or virtual machines, they started actually consuming cloud resources. And by doing that, they needed to actually implement a methodology that created this role of being a DevOps, a development operative or a development operations, DevOps. It was always there. The only difference that we weren't able to actually visualize them. And it came from a model that was not growing naturally and it was not growing effectively. And it moved into development completely. So the developers actually inherited all the problematics of the IT infrastructure, the security, etc., without the understanding about how they were going to address those issues. So it was made by developers for developers. The concept of DevOps comes into the famous design that you've seen hundreds of thousands of millions of times, which is built into the content, continuous integration and continuous delivery. You always plan, code, build, release, deploy, operate, and monitor. And it starts again and again and again. When you look at the stack of tools and applications that you can use in each of the actual different steps of your DevOps pipeline, you're going to see that there are hundreds of them. In fact, when you look in the actual cloud native landscape, which is the number of vendors and applications that exist there, you can even print it on an A0 as a piece of paper, and it won't be even enough to read the names. I can barely see what names are there. And imagine that when you get into the full picture, you understand that it's a totally heterogeneous ecosystem. Each of them are actually building a part of the solution. When we come to the serverless landscape, we still get actually the same. There is too many players for too many services. So everyone is actually doing something that helps the ecosystem of serverless. So you can have people doing security or tools or a framework or who is hosting the platform. Again, is the same logic. Too many players. A DevOps wants today to build secure, to ship fast, so actually deliver the product fast and run it anywhere. So building secure means that it has to meet compliance and security in order to be able to be delivered. Shipping fast, it means that the security needs to be automatically integrated into the pipeline of development to reduce the problem that we have between the security teams and the devs and the business, that there is a friction always there. And then it has to run everywhere. So you don't want to build it multiple times for multiple different targets. You want to build a solution, a product. Your code needs to run in any place. So that's what happens, is that the people who are behind the DevOps management, they get to the situation where there is no there is a blame. There is no chance not to be actually impacted by this problematic. So the CISO is very angry. It always wants to change who is managing the DevOps pipeline and who is managing the DevOps environment, because there is a lack of integration of a proper security into it. And on top of that, you also have the fact that there's a lot of friction. So people are actually getting against each other while working for the same goal. One wants to ship and deliver the product, the other ones want to deliver something securely. So the challenges also that have come in the last 2 years is that there are new security conditions, and there have been a lot of COVID situation challenges. The dynamics of the infrastructure have evolved. The speed of the change of the applications has evolved too. And the threats have become more sophisticated, which means that there is a huge increased footprint for the audits and security protection. There is also an ecosystem that is totally hybrid across the different clouds used, or even on premises. And there are less and less resources ready to actually help the business. So that leads us to the paradigm of the model coding. So people want to build code today, or they are building it with the use of all the new tools and the new objects and artifacts they have got into their environments. And then we get to the different points. So the legacy security innovators adopt the change for security very slowly. The speed of coding is very fast, but the amount of code is also very, very big. The modern model coding techniques are differentiating themselves compared to the old coding. We don't code anymore in assembler. We don't create code that is actually used in cloud native applications that is based on assembler. So we use model code that is more and more complex. The controls are very difficult to set in place because they stop the speed of the development, and there is a lot of complexity behind that. The outcome is that we have a lot of tools that have been created to support each scenario. So every time there was a problem, somebody thought, oh, well, I need to fix this problem with a tool. Oh, there is a new problem here. I need to fix this problem with a tool. And then the tools started increasing the numbers. That's why the cloud native foundation landscape is so huge. There is a huge risk, and it is a real one, to create bad code fast and ship it. The adoption of containers in production is just growing. The adoption of Kubernetes is growing. It's just a question of a few years, maximum 5 years, that most of the companies in the world will be running into containerized applications and using Kubernetes. And the vendors that are providing security, they need to rebuild their solutions to actually provide a newer cloud native approach to an answer for a security requirement in the organizations. They cannot use the traditional security tools to protect the newest cloud native solutions. So the landscape is always the same about the pain for the DevOps. So there is more complexity, there is a problem of security slowing down, there are tools that are incompatible with the model that they're using. It's very difficult to take the tools and integrate them. And there is the problem of I waste too much time providing answers for compliance. I miss my go-to-market timing is gone because I need to go through all the different security elements. And there is a lot of overhead when there are multiple environments and different tools used. Now we're going to talk about the three concepts. Where do we put the word sec into the different into DevOps? So if we put it at the end and we say DevOps sec, it means that it is at the end. It's when we have already delivered the application that we're going to run the security, which means that we're going to do it when the application is already there, compiled, created, and we're going to run testing. We're going to do black box, white box checks. We're going to do pen testing to see if when the application is running if it's vulnerable or not. We're going to inspect memory. We're going to do dynamic assessments of security and runtime assessments of security and pen testing. And then when we find vulnerabilities, we go back and then we patch them. This is the next scenario here. The 2017 Equifax breach was caused because an open source application, which was Apache Struts, was not patched. And that was the source of the attack. When we put the word sec in the middle, DevSecOps, then we break development and operations into two. So we leave the developers to their job, but at some point, we address the security while they are actually in the middle of building it. And then it comes as a streamlined process where we look for what they are doing and before they publish, so we are sure that they're publishing something secure. And operations can get less overhead because they don't have to actually build their solutions at the very end of the line when they are monitoring or operating the solution. Sec in the beginning, Sec DevOps, means that we're gonna do all the practices and all the best efforts in the beginning, which means that we're gonna have to integrate the InfoSec teams with actually the development team. We're gonna have to educate the developers, so there's a lot of effort in enablement and education. We're gonna have to make people be sensible for the actions they take when they're building, when they're actually operating and building in the development team. So here, everything starts in the developer. I like to talk about the fact that we are trying to go we try to go for this model as much as possible. At the moment, we are in the DevSecOps, but we need to get to the Sec DevOps. Everybody needs to be transparent in security, and everybody needs to see security as an additional ball pen that you have to take notes. It's a tool. It's part of what your daily job. You look into security as you do your coding. People do infrastructure and they look for security. Why people in the development space won't look for security as a tool, as a medium for them, a vehicle for them to get their job done properly and do not have to correct it back. Now, samples that you can have in an attack in a pipeline, continuous integration and continuous delivery. For example, could be forked bombs inside containers, for example, processes that they never stop. There's a number of processes. The container is working, but it gets overhead because of the number of processes. There is also the problem of containers talking to each other when they're not supposed to do it. So that's an unwanted communication. You also have the unauthorized pivot traffic, which is in an advanced persistent threat, in the phase 4 of it, is called the lateral movement, how a malicious piece of code and an attack moves across different containers. You can also have rogue images of containers that should not be there, that have been dropped by some malicious actor. You can also have orphan images that nobody has a control over them, and they are just forgotten in your repositories. You can also have rogue processes running, executing malicious contents that are not actually controlled or visible to you, or libraries being used that they are not supposed to be there either. Or volume mounts that stay persistent even after the container has been killed. That's also one of the cases of potential security breaches, if you don't prevent that those volumes are just destroyed after the or dismounted or mounted, sorry, after the container is killed. Then there is a classical example, the cryptojacking container source, which basically you either create a container for crypto mining, or you infect a set of containers to actually generate crypto mining on the resources of an organization. You also have the C2C communication, which are the command and control, or fileless attacks. And in fileless attacks, that's where the example that we're going to see. The fileless attack means that I produce an attack without having to copy content into the drive. Without to have a file created, I can just run and execute the malicious code in memory. In this case, we have a sample of the Kinsing malware attack tree that happened into a set of customers, and it is delivered by, it's an analysis done by InfoSec. And it's very simple. The attacker just connected to an API port that was left in a Docker daemon without being supervised. It ran a container, which was an Ubuntu container, which downloaded a malicious shell script. Then eventually it connected to this IP address to do that. That script was actually executed, which first created a cron tab job to stay persistent. Then it downloaded the malware from the malicious side. Eventually, it ran the malware, which downloaded a script, and downloading this malware was executed in memory. It then eventually downloaded a lateral movement script to start going across the different potential other containers and resources by looking into credentials and keys in the key vault. So basically, it was actually looking to how to expand itself. It was very nice because then it ran the crypto miner, which eventually started mining on the resources of the organization and connecting to and reporting the results back to the command and control, which are all the IPs that you see there. The previous example, it is then mapped into the Mitre attack. So the Mitre attack is a fantastic framework that tells you techniques and tactics used by your adversaries when they try to attack you. So you go there, read it. It's superb. It's amazing because it gives you visibility of all type of different attacks and what type of maps do you have. So in that case, we have the map of the previous attack into a Mitre matrix. Any Mitre matrix can actually be defined for any type of attack. The only thing you have to do is basically state and push the different areas that they were covered. In that case, for example, it was bash history, looking for the private keys. The lateral movement was done there also. There was an impact on resource hijacking. The persistence was done with the local job scheduling, which is what we saw here. Runs a cron tab job for persistence. So everything that happened into that malware attack was mapped to this Mitre matrix. So how do we fix the issue? Well, what we need is a framework that is actually frictionless. It integrates into the pipelines without any problems. It looks into the zero-day attacks and early indicators of attack. It monitors continuously in real time for any possible threat. It looks also into the historical and behavioral logs of activities in order to do forensic analysis. It has to be the lowest. It has to have the lowest impact into the DevOps operations, and it has to be very effective to deploy. The DevOps team needs to also look into how they're going to harden their pipeline for continuous integration and continuous development, how they're going to monitor the pipeline, how they're going to do arbitrary audits like this to look for potential statuses of indicators of compromise or indicators of attacks. They have to use trusted secret managers for credentials, keys, secrets. They have to be removed. Everything has to be actually analyzed top to bottom and make sure that nothing is visible or accessible. A role-based access control to make sure that there is a kind of control to make sure that only the right resources and the right objects have the right accesses. The logs have to be immutable, so nobody can remove their traces of their operations. Add obviously container security, Kubernetes security, and you have to add code analysis tools, which means that you have to analyze the code from the beginning, from the laptop of the actual user, the actual coder, the actual developer. So the application securities in the CI/CD pipeline will be based on the fact of analyzing in real time static analysis of the code in the development environment of the actual developers. Then looking into static analysis when they are committing to make sure that there are no differences. Then when they're building, do static code analysis and also static analysis. In the testing, then you do the dynamic analysis, and then you look for potential hardening and fuzzing checks in order to see if the application is actually secure. You can do also a potential first type of pen testing. Then you deploy, and then you go in production. When you go in production, you start doing the pen testing. You can do it as a white box, or you can do it as a black box, or even as a gray box when you know a little bit of the information of that application. I'm not going to stop too much here because it's too much of information, but basically it's telling you the differences between SAST and SCA, and also between static and dynamic analysis. So when you look into the application, one is about application, the other one is about code, while static application security and dynamic application security will be the difference when one is just the application without being run, and the other one is when the application is running. The controls that you put in your pipeline are based on building a scan solution for security into the Jenkins, into the pipeline. I put some codes here and names just to have some famous and common references, but it could be anything, any possible competitor there. So you're gonna put actually your build scanning. Then you're gonna scan your registries where you're gonna put your images. Then you're gonna have an admission control, which was what I was explaining with the airbag, who can do what and where and how. Then you're gonna do a runtime analysis for security. That's gonna be a runtime analysis of the application. Then you're gonna look into the platform itself, okay, the engines, Kubernetes and Docker, and also the engines for any type of engine that you may be using for containerizing, container engine that you may have. Then you're going to look into the host because finally everything runs somewhere. So you're going to have to run it into a platform. Eventually either is a physical or is a virtual one. And you're going to have to protect it and analyze it. And then also the intrinsic protection that you're going to add to containers and also serverless. You have to identify the issue before the deployment. So what happens is that you need to stop it before it gets deployed. And obviously, there will be all the risks that you're going to find always. Actors that are going to inject malicious code into the pipeline, the problem of using open source and vulnerable code into your deployment, into the development applications, the use of the wrong dependencies without checking them that they may have vulnerabilities. And how do you mitigate them? By finding with vulnerability assessments when you have remote exploits or local ones, by doing a shielding against the vulnerabilities, by detecting the malware via signatures and machine learning, by continuously scanning your CI/CD pipeline, by looking into the historical data to actually see if you missed something from the past, by managing the immutability of your environment, and obviously by having a full automation behind it. And the future is going to be very complex because it's growing very fast. But what we're looking here is that we can be compromised at any stage into the CI/CD pipeline. And the logic is to make sure that we are using the next generation solutions for code analysis, for static application security analysis, for dynamic application security analysis, for real-time application security testing, using machine learning, AI, behavioral and historical analysis, the newest type of anti-malware solutions, shielding yourself against the vulnerabilities, sandboxing if you can detonate the threats that are 0 days, and obviously, because everything is about a combination of the developers, the operations, and you have to subtract behind that all the integration of the security. Better to be proactive rather than to have to regret it later. It's good.
Thank you so much. Thank you so much, Jesus, for this wonderful and informative presentation. I'm sure that all our audience must have a lot of learning in this presentation. It was very wonderful and very detailed, I must say. So I think we are running out of time. So unfortunately, I cannot take the question and answer. But I would just encourage everyone to visit the booth or talk to or reach out to Jesus personally. I think I'm sure that he will be on LinkedIn as well. So I would suggest that you reach out to him and ask the questions if you have any.
Absolutely.
Yeah. Thank you so much for your time, everyone, and especially to Jesus for your that you are here with us today and sharing your wonderful knowledge.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
Bye-bye.